Questions 19 through 22 tackle information about fracking in the US between 2005 and 2012. There's a large set of text and also a table, which I'll put in here. It's often a good tip to look ahead and see what's actually being asked. So in questions 19 and 20, we can see that we're being asked numerical questions pertaining to the data in this chart. Whereas if we look ahead, we can see that 21 and 22 are actually just asking critical thinking questions based on the text. So if we want to start by tackling 19 and 20, we should focus on the chart. Question 19 asks the following. The number of wells drilled in Oklahoma in 2012 is unavailable, which we can see here. Assuming it rose by the same proportion as neighbouring Texas against the 2005 to 2011 average, which of the following would be the best estimate of the missing number? So what we're looking for is this value here, which is unavailable. To help us find it, we're told that the average of this value here over the 7-year period 2005 to 2011 rises by similar magnitude as the average of the Texas value over the 7-year period to 2012. So just to make us remember, we should write down 7 years and then we can work out the averages. Now bear in mind that the answers are quite far apart and we're being asked for the best estimate. That gives us some license to round down or round up for our convenience in the calculations. So we can estimate the 33,753 value here in Texas to be roughly 35,000. So when we divide that by the 7 years between 2005 and 2011, we get 5,000. We can also say that the 13,540 in 2012, which we're comparing the average to, is about 15,000, which works because we're overestimating both times. Therefore we can say, between the two of them, there is a threefold increase. So for Oklahoma, we can roughly estimate that this 2,694 is about 2,800, again an overestimate. Divide that by 7, we get 400, which we know, multiplied by the 3, the same threefold increase, we're looking for a value around 1,200, in fact a bit lower, given that this is an overestimate, as above. We can see that the answer C is clearly the closest, at 1,081. Question 20 tells us the amount of water used per well varied significantly between the states over the period from 2005 to 2012, so that would encompass both columns. Of the states for which the data was available, Louisiana had the highest value, so the highest value of water used per well, so we can see this relation here, and Utah had the lowest value, which we can see here. What is the difference between these two values? That's what's being asked. So, starting with Louisiana, the amount used per well can be seen to be 12,000, which you derive from the table, over the 139 for 2012, and also, the 2,327 from 2005 to 2011. That spans the entire 2005 to 2012 window mentioned in the question. Once again, the question does tell us that we can estimate the answer, so that gives us the scope to round. So we can say this is roughly 12,000 over 2,500, which is just under 5, and the units are millions of gallons. So let's quickly go through Utah. So the 590 millions of gallons used can be divided by 765 and 1,336, and again we can estimate this to be 600 over 1,800. And as a rough estimate, this is 0.3 million gallons. So the task is to compare the two, which we can see would be roughly 4.7 million. Then if we have a look at the answers, we can have a look and see that C is the closest with 4.5 million. So we can say this is our answer. So let's turn to question 21, which is a critical thinking question, where we're asked which of the following can be concluded from the information in the table and the text. So let's quickly go through the information in the text. The oil and gas industry has increasingly turned to hydraulic fracturing, known as fracking, a highly polluting effort to unlock oil and gas in the underground shale beds in the United States. Fracking is already underway in 17 states, with more than 100,000 wells drilled since 2005. Since 2005, fracking has used nearly 250 billion gallons of water across the nation. The greatest total water consumption occurred in Texas, at the same time as the state was struggling with an extreme drought. Fracking fluid consists of water mixed with chemicals such as benzene that is pumped into underground frac wells. Although in percentage terms the chemicals are a small component of fracking fluid, but the total volume of chemical used is immense. According to the oil and gas industry, 99.2% by volume is water, the other 0.8% is a mix of chemicals. These can enter the drinking water supplied from the well or in the wastewater disposal process. Completion of fracking wells from 2005 to 2012 produced global warming pollution equal to CO2 emissions from 28 coal-fired power plants in a year. And both water consumption and pollution levels varied sharply from state to state. Okay, let's look at the three options, bearing in mind that we can pick any or all of them in any configuration. So let's start with one, which says that the fracking fluids from Texas 2005-2012 contain 880 million gallons of chemicals which risk contaminating drinking water. Well, let's assess the qualitative aspects of this. So risking contaminating drinking water is something that we've seen in the text. And we've also seen in the text that the chemicals consist 0.8% of the total fracking fluid. So what we're looking for is essentially less than 1% of the water used. So if we look at the table, 110,000 million gallons was used in Texas. So 100th of that, i.e. 1%, would be 1,100. And we're looking at slightly less than that, which 880 appears to check out on. So we can say that this is true. So question 22 is asking, which of the following, if true, would offer a convincing explanation for the wide variation in water consumption per well, which we can write down, in different states? Something we identified in question 20. Let's look at number 2, which says that a typical coal plant releases 36 million tonnes of CO2 a year. So from the text we know that the national sum of the fracking is 28 coal plants a year. So we should be looking for a 28 of the total. As we can look at the total amount of tonnes emitted from all of the fracking plants, we can see that it's 100 million. So 36 million is not a 28th of 100 million, so we can say that this is false. Finally, 3 says that a typical Colorado household uses 130,000 gallons of water a year. Now we know that Colorado used enough in 1 year for 200,000 households to get water. So let's get that 200,000 down and multiply it by 0.13 million gallons of water, which is the same as 133,000. And we can see that the decimal place has to move 5 places, leaving space for 3 more, and then multiply by the 2 to give us 26,000. Let's check the table. And we can see that for Colorado, 26,000 exactly was used in terms of the water for 2005-2012. So that's our answer. As statements 1 and 3 were correct, the answer is E. Moving on to question 22. Option 1, water supplies are plentiful in some states, and that explains the variation. Well, we know that Texas used 250 billion gallons of water, the most of any state, despite there being an extreme drought, so this is an unconvincing explanation. Option 2 says that technology developed slowly over the lifetime of fracking, but that doesn't explain the variation between states at all, so this must be incorrect. Finally, 3 says that some states have drilled more wells. Well, we know that Louisiana and Utah, from the previous part of the question, used the extremes of water per well. So Louisiana used the most, Utah the least. But they all fall in the middle if you rank all of the states by the amount of water used. So if we were to jump to the statement, some states having drilled more than others does not determine the variation in the usage per well. So given that none of them were true, the answer is H.